Dear students, in this episode we are going to discuss on weather and climate, definition and significance of climatology, elements of weather and climate, composition and structure of the atmosphere. This module consists of the following modules: definition and significance of climatology. The second one is difference between weather and climate, elements of weather and climate, factors that determine weather and climate, composition and structure of the atmosphere. First of all, let us see the definition and significance of climatology. Climatology is a science that seeks to describe and explain the nature of climate, why it differs from place to place, and how it is related to other elements of natural environment and to human activities. The term comes from the Greek word klima, referring to the supposed slope of the earth and approximating our concept of latitude, and logos, a discourse of study. Climatology is closely allied with but often confused with meteorology, and although they study similar things, they are separated by the length of time over which they operate. Climatology is a branch of atmospheric science concerned with describing climate and analyzing the causes and consequences of climate differences and changes. Climatology treats the same atmospheric process as meteorology, but it also seeks to identify slower acting influences and long term changes, including the circulation of the oceans, the concentration of atmospheric gases, and the small but measurable variations in the intensity of radiation. So, the scientific study of climate deals with the mean and the variability of the weather conditions for a particular location, season, and time of the day. The climate is often described in terms of the mean values of meteorological variables such as temperature, precipitation, wind, humidity, and cloud cover. A complete description also includes the variability of these quantities and their extreme values. Climate also exhibits significant year to year variability and long term changes on both a regional and global basis. The goal of climatology are to provide a comprehensive description of the Earth's climate over the range of geographic scales, to understand its features in terms of fundamental physical principles, and to develop models of the Earth's climate for sensitivity studies and for the prediction of future changes. Now, let us see the difference between weather and climate. What is weather? Weather is the state of atmosphere at a given time and place. It is the day to day state of atmosphere, and its short term may be minutes, 2 weeks variations. Popularly, weather is the combination of temperature, humidity, precipitation, cloudiness, visibility, and wind. A complete description of the weather includes the amount of types of clouds, rain, snow, thunderstorms, lightning, and even dust storms are part of the weather. Measurements of temperature, pressure, wind speed, and direction of the amount of moisture in the air are also included in the description of the weather. Weather is studied and predicted by scientists called meteorologists. The science of meteorology is the study of entire atmosphere, including its weather. To understand the predict the weather, meteorologists must first understand how the atmosphere heats and cools, how clouds form and produce rain, and what makes the wind blow. Meteorologists also study subjects not obviously related to weather. Such subjects include the composition of the atmosphere, the atmospheres of the other planets, and the causes of past and present climates. Let us see what is climate. Climate is defined as statistical weather information that describes the variation of weather at a given place for a specified interval. In popular usage, it represents the synthesis of weather. More formally, it is the weather of a locality averaged over some period, usually 30 years, plus statistics of weather extremes. We talk about climate change in terms of years, decades, or even centuries. Scientists study climate to look for trends or cycles of variability, such as the changes in the wind pattern, ocean surfaces, temperature and precipitation over the equatorial Pacific oceans that results in El Nino and La Nino. And also to place cycles or other phenomena into the bigger picture of possible longer term or more permanent climatic change. Elements of weather and climate includes temperature, and then temperature is a very important factor in determining the weather, because it influences or controls other elements of the weather, such as precipitation, humidity, clouds, and atmospheric pressure. Humidity is the amount of water vapor in the atmosphere which is measured in percentage. Precipitation is the term given to moisture that falls from the air to the ground. Precipitation includes snow, hail, sleet, drizzle, fog, mist, and rain. Atmospheric pressure is the weight of the air, which is measured in millibars, resulting on the Earth's surface. Pressure is shown on a weather map, often called a synoptic map, with lines called isobars. Wind is the movement of air masses from the high pressure areas to low pressure areas. Now, let us see the factors that determine the weather and climate. So, what is weather? The key elements affecting weather are temperature, humidity, and air pressure, all of which are influenced by the uneven heating of Earth's surface by the sun. Temperature is largely determined by this amount of solar energy in the atmosphere in a given location. This varies according to the number of hours of sunlight received per day and the angle at which it strikes the earth. Other factors affecting temperature are reflection and scattering of the sunlight, cloud cover, absorption by gases in the atmosphere, and conditions on Earth's surface. Solar energy drives the water cycle and affects the amount of humidity in the atmosphere. Water on the ground evaporates and rises into the atmosphere as water vapor. Under the right conditions, it condenses into clouds and returns to earth as precipitation. Air pressure is also affected by solar heating. Differences in air pressure causes local winds when air flows from high pressure to low pressure areas. An air mass is a large body of air that has a uniform temperature and humidity. Since cool, dry air is denser than warm, moist air, a cold air mass will move under a warm air mass and push it up. As the warm, humid air rises, it condenses and forms clouds, resulting in precipitation. The boundary between two air masses is called a front, named after the battle lines where opposing armies clashed during the First World War. Factors that determine the climate. Climate is comparatively constant because it is largely determined by an area's latitude, the distance above or below the equator. Due to the 23.5 degree tilt of the Earth's axis relative to the Sun, the equator receives more direct sunlight than anywhere else on Earth. Therefore, the equator has the highest year-round average temperature, while the poles, which receives the least amount of sunlight, have the lowest average temperature. So, other factors affecting climate include altitude, mountain ranges, and proximity of large bodies of water. Finally, let us see the composition and structure of the atmosphere. First, let us see the composition of the atmosphere. The atmosphere can be described as, I quote, a blanket, unquote, of air surrounding the Earth. This mixture of gases contains huge number of solid and liquid particles. Two gases, nitrogen and oxygen, make up 99% of the air. Other gases constitute about 1%. At sea level, following gases comprise the air: nitrogen, oxygen, carbon dioxide, neon, helium, ozone, hydrogen, krypton, xenon, and methane. Besides, large number of water vapor and dust particles are also present. Of all these gases, oxygen happens to be the most important, which is so essential to all life forms. The following table gives the composition of the air. All living organisms inhale oxygen. It is essential for most combustion. When any substance burns, oxygen is consumed. Nitrogen is another gas which about 78% of the atmosphere's volume is made up of. Its main function is to regulate combustion by diluting oxygen. The third important gas is the carbon dioxide, which is the product of combustion, constitutes only about 0.03%. Being an efficient absorber of heat from the upper atmosphere and considered to be of great climatic significance. Despite of the fact that portion of carbon dioxide is relatively constant, its percentage is gradually rising. It is estimated that from 1890 to 1970, the content of carbon dioxide has increased more than 10 times. This is a matter of great concern to all of us. Let us see the structure of the atmosphere. The Earth's atmosphere has 5 primary layers, referred to as spheres. From the lowest to the highest layer, they are the troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. The 4 boundaries between the primary layers, referred to as passes, are the tropopass, the stratopass, the mesopass, and the thermopass. Let us see these passes in more in detail. troposphere. The troposphere is the lowest and thinnest layer of the atmosphere and extends from the Earth's surface to about 7 kilometers high at the north and south pole and 17 kilometers high at the equator. This is where we live. As the density of the air in this layer decreases with height, the air temperature in the atmosphere also decreases with height. The temperature drops from about 14 to 15 degrees Celsius at the surface to about minus 45 degrees Celsius at the top of the atmosphere. All of our weather occurs in the troposphere. Almost all clouds and precipitation from the troposphere, weather fronts, hurricanes, thunderstorms are tropospheric phenomena. The troposphere contains about 80% of the total mass of the atmosphere. In fact, 50% of the total mass of the atmosphere is located in the lowest 5 to 6 kilometers of the atmosphere. Tropopause. The boundary between the troposphere and the stratosphere is the tropopause. Together, the troposphere and the tropopause are known as the lower atmosphere. The stratosphere, from the Latin word stratus meaning spreading out. The stratosphere extends from the tropopause height of 7 to 17 kilometers to a height of about 50 kilometers and contains about 19% of the atmospheric gases. The stratosphere experiences increasing temperature, solar radiation with height. It contains the ozone layer because the solar radiation is increasingly absorbed by oxygen molecules in the stratosphere, leading to the formation of ozone. The ozone layer resides in the lower portion of the atmosphere, though the thickness of the layer varies seasonally and geographically. The temperature usually stops decreasing. It becomes roughly constant at first and then begins to increase with height. The air in the stratosphere is very dry, generally having less than 0.05% of the maximum amount of water vapor found near the ground. Clouds are very rare here except for occasional thunderstorm penetration in the lower part. The temperature increases in the stratosphere because of the presence of ozone. Ozone's absorption of ultraviolet radiation leads to warmer air that can sometimes reach temperatures as high as those found at the ground. Stratopause. The boundary between the stratosphere and the mesosphere is the stratopause. This atmospheric pressure here is about 1 by 1,000th of the atmospheric pressure at sea level. What is mesosphere? From the Greek word meso meaning middle. The mesosphere extends from stratosphere's height of about 50 kilometers at a height of about 80 to 85 kilometers. The gases continue to become less and less dense with height. As such, the effect of the warming by ultraviolet radiation also becomes less and less, leading to a decrease in temperature with height. On average, temperature decreases to as low as minus 100 degrees Celsius at mesopause. Mesopause. The boundary between mesosphere and the thermosphere is the mesopause. It is the coldest place on the earth with the temperature as low as minus 120 degrees Celsius at times. Let us see the thermosphere. The thermosphere extends from the mesopause height of about 80 to 85 kilometers at a height of between 500 to 1000 kilometers and is referred to as the upper atmosphere. The gases of the thermosphere are increasingly less dense than in the mesosphere. As such, increasing high energy ultraviolet and X-ray radiation from the sun absorbs by the molecules in this layer results in the temperature increasing to as high as 2000 degrees Celsius near the top of the layer. However, despite the high temperature, this layer of the atmosphere would still feel very cold to our skin because of the extremely low density of the air. The total amount of energy from the very few molecules in this layer is not enough to heat our skin. Thermopass. The boundary between the thermosphere and the exosphere is the thermopass. Extends from the tropopass height of 500 to 1000 kilometers up to a height of 10,000 kilometers above the Earth's surface. The exosphere is the outermost layer of the atmosphere, and it is in this layer that our man-made satellites orbit the Earth. The density of the exosphere is so low that particles within it do not collide. As a result, particles in the exosphere can escape altogether from Earth's atmosphere into the space. There are two other regions of the atmosphere that deserve discussion. One is the ionosphere and the other is the ozone layer. Ionosphere. Solar radiation causes ionization of the molecules in a region of the atmosphere that extends from about 50 kilometers up to about 1100 kilometers above the Earth. That region is called the ionosphere, and the most of it is in the thermosphere, although it overlaps into the exosphere and above the thermosphere and the mesosphere below the thermosphere. It is of importance because certain regions of the ionosphere make long distance radio communication possible by reflecting the radio wave back to the Earth. Ozone layer. Though part of the stratosphere, the physical and chemical composition of the ozone layer is far different from that of the atmosphere. Ozone, O3, is the Earth's atmosphere is created by ultraviolet light striking oxygen molecules containing two oxygen atoms, O2, splitting them into individual oxygen atoms. The atomic oxygen then combines with unbroken oxygen to create O3, the ozone. Ozone is unstable, and when ultraviolet light hits ozone, it splits into a molecule of O2 and an atom of atomic oxygen, thus creating a continuing process called the ozone oxygen cycle. This occurs in the ozone layer, the region from about 10 to 15 kilometers above Earth's surface. About 90% of the ozone in the Earth's atmosphere is contained in the stratosphere. Ozone concentrations are greatest between the highest of about 20 to 40 kilometers above the Earth's surface, where the range from about 2 to 8 parts per million by volume. Summary and conclusion. Weather is the instantaneous state of the atmosphere or the sequence of the state of the atmosphere as time passes. As we know, the behavior of the atmosphere at a given place can be described with number of quantities characterizing the physical state of the air, such as the temperature, pressure, water content, motion, etc. The temperature, pressure, wind, precipitation interact with each other. The influence of atmospheric conditions like the direction and velocity of the wind amount of insolation, cloud cover, and the amount of precipitation will greatly affect the weather and climate of a region. The influence of these elements differ from place to place and time to time. Temperature being a very dominant factor in determining the weather and which varies greatly with altitude, there is a need to understand the atmospheric zones, and the properties consist of temperature, density, pressure, and chemical and electrical properties of these layers. They affect the incoming solar radiation and the heat budget of the atmosphere. In the next episode, we will be discussing on the factors affecting the distribution of insolation and the heat budget.